So for our final discussion of double replacement reactions, we've looked at, of replacement reactions, we've looked at single replacement reactions, we've looked at how we determine whether something is soluble or insoluble, whether it's going to form a precipitate. And with that information, we're going to be able to now to move on to being able to predict what the products of a double replacement reaction would be and if that reaction would actually work. So looking at this first one, we've got aluminum chloride and silver nitrate. And again, it might be easier if you wrote it in words. You don't have to, which is why it's in green. And since both of these are compounds, remember I want you to put whether they're compounds or elements, we know that this is going to be a double replacement reaction. So in a double replacement reaction, what we want to do is to flip out the first two elements. So we're going to take aluminum and silver, and we're simply going to trade places with them. We don't have to figure out whether they're metals or nonmetals. That's only for single replacement reactions. But now the silver is going to go with the chloride, and the aluminum is going to go with the nitrate. I'm running out of room, so I'm going to squeeze. I guess I'm going to have to put the nitrate down here. Squeeze it in. So let's write that as a formula reaction first. We've got aluminum with the chloride, skeleton. I'm just going to do the skeleton first. I'll come back and find charges in just a moment. The silver with nitrate. Okay, oh, well, we don't have to find charges. They already gave us that part, so don't worry about that. But now over here, we do need to know our charges. Silver with the chloride, and silver's a +1, and chloride's a -1, so that doesn't need any subscripts. Aluminum nitrate, aluminum with the NO3. Aluminum is a +3. Nitrate is a -1. So we will need to get this compound balanced out. Looks like we need 3 nitrates to go within aluminum. So in order to determine whether this is going to actually react or not, something has to happen. We have to have a driving force. And we're going to be focusing this year on whether it forms a precipitate or not. I mentioned that in the previous notes. In the previous set of notes, the previous video, we also talked about how we knew whether something was a precipitate or not. If there is no precipitate in this reaction, this does not occur. It will not work. It has to be a precipitate, so that's what we're going to look for. Now, I always try to find always soluble substances first because they're never going to form precipitates. So looks like right here we've got nitrate. Nitrate, remember, is one of our always soluble ions. So that is not going to form a precipitate, so that's not it. Silver chloride, on the other hand, this is actually one of the ones that we looked at in the earlier video. Silver is, neither silver nor chloride are in the always soluble ions group, so we had to look those up, and I'm going to briefly do this. We have already discussed this, so I'm not going to spend a lot of time on this. You can go back and watch that video if you want to remind yourself how to do this. But here's our chloride right here. And it's in the soluble list, but silver is an exception, so that automatically makes it insoluble. So going back here, what I want you to do to show that this is insoluble is I want you to draw a down arrow to show that this is a precipitate. So you've got to show that this is a precipitate. And the other substance, since it is not a precipitate, I'm going to ask you to put aqueous. That means that it's soluble, that it dissolved in water. I'm not going to make you put the rest of the symbols, although the rest of them would be aqueous anyway. I'm going to let you do that for extra credit on the test. But for now, you don't have to put it. But the ones that I put just now in blue have to be there. So again, if you want to, you can put that these are aqueous, but you do not have to right now. So this will work. So now I'm going to balance it. If it didn't work, I would just put no reaction and move on. But it does work. Looks like I have 3 chlorines in the left, and I'm going to need 3 on the right. And now that I have those 3 silvers, I'm going to need a 3 here to get my silvers balanced, which very nicely balances my nitrates as well. So this is the final reaction for this one. The next one says a yellow precipitate is formed. Well, that was a dead giveaway because a yellow precipitate means that this reaction will work. I don't have to worry about that. It says when an aqueous solution of potassium chromate is mixed with an aqueous solution of lead 2 nitrate. So we've got potassium chromate plus lead 2 nitrate. And when they react, I'm going to run out of room, but when they react, remember, our first 2 elements are going to trade places. And when they do, I end up with, and I'm just going to write it below, lead, the Roman numeral follows, lead 2 chromate and potassium nitrate. So they just get new partners. And now all we have to do is to write the skeleton equation for this. We've got potassium with chromate, CrO4. Remember, 8 or ite means we're dealing with a polyatomic ion, so make sure you're remembering that. So potassium with chromate, lead 2 with nitrate. Nitrate ends in ATE, so it's going to be a polyatomic ion. We need our charges. Potassium's a +1, chromate's a -2. So that means we're going to need 2, whoops, did that in green, meant to do it in blue. We're going to need 2 potassiums to balance out that compound. As it's set up here, lead is a +2 because of the Roman numeral. It told us it was a +2. Nitrate's a -1 when we looked that up on the polyatomic ion list. So it looks like we're going to need 2 nitrates to balance that out. Then lead 2 chromate, we've got Pb with the CrO4, and we just established up here that lead was +2 and chromate was -2. So that's not going to need any subscripts. And potassium with a nitrate, and we just established above that potassium was a +1 and nitrate was a -1, so that's not going to need any subscripts. So we're good on both of those. Now, before we go to the trouble to balance it, we need to decide if this is even going to work or not. So let's look at lead chromate first of all. Well, first of all, let's see if we've got any always true ions up here. And it looks like we've got nitrate and we've got a group 1A element. And as soon as we have both of those, that's like doubly soluble. So that is definitely not going to be our precipitate. So we could go ahead and put a little AQ after that, because that's not our precipitate. And we know there's going to be one because it just told us up there was a yellow precipitate. So we don't really have to look up lead chromate, but let's just go ahead anyway. If we look on this sheet, we'll see that chromate, CrO4, is down here on the insoluble list, and lead is not one of the exception elements. So this is an insoluble compound. This is going to be our precipitate. So what do we do when it's the precipitate? We put a down arrow after it. And now let's put our blanks in front so we can balance it. Looks like we need, if we just put a 2 in front of that potassium nitrate, looks like we get our 2 potassiums and 2 nitrates on each side. So looks like that's all we needed to do. The other 2 are both aqueous, it said, so we could put little AQs after it, but we do not have to. That's why they're in green. Our next one, because we have an aqueous solution of zinc 2 nitrate, is reacted with an aqueous solution of sodium phosphate. So maybe if I write it far enough to the left, I can get it all in. I don't know, but we've got zinc 2 nitrate plus sodium phosphate. Maybe a little planning ahead will help me this time. And when they're both compounds, so since they're both compounds, I know it's double replacement reaction, and that means the first element in each compound is going to switch places. So when they switch places, I now have sodium with nitrate, and I have zinc 2 with phosphate. Okay, let's write our skeleton equation. We've got zinc with nitrate. Nitrate means there's going to be a polyatomic ion there. And we've got, that's just a skeleton, we haven't found charges yet. We're adding that to sodium phosphate, and phosphate ends in 8. Look on your polyatomic ion list, it's PO4. So now I need to find charges. The Roman numeral tells me that zinc is a +2. I look up nitrate, it's a -1. So it looks like I need 2 nitrates to balance this. Sodium is a +1. I look up phosphate. Phosphate's a -3. So it looks like I'm going to need a 3 after the sodium to get this balanced. Now that I've got all of the substances found on the left, all I have to do on the right is just get them put back together again, the sodium with the nitrate. So since sodium was +1 and nitrate was -1, don't need any subscripts. Zinc with the phosphate, find charges. Zinc is a +2. We saw over on the left. Phosphate's a -3. What can we do with a 2-3 combination? Cross them. So it looks like we've got a 3 with the zinc and a 2 with the phosphate. So we've got the reaction done. Now we have to decide if this is actually going to work or not. See if there's a precipitate formed. It has to be one of the, we don't care about the 2 substances on the right. We already know that they're aqueous, and we don't have to, but again, we can go ahead and write that they're aqueous. Now let's look at the 2 substances on the right-hand side though. Is one of them automatically soluble because it has one of our always soluble ions in it, and it looks like we're dealing with sodium nitrate here because sodium's a group 1A element and nitrate's one of our always soluble ions. So that's, again, like double soluble. So our only hope is zinc phosphate. It doesn't contain any of our always soluble ions, so let's see what we've got when we go check our solubility chart. Phosphate or zinc should be somewhere on here, and it looks like phosphate's right here in the insoluble list. So unless zinc is an exception, it looks like we found our precipitate. Zinc is not an exception. The only exceptions are ammonium and our group 1A elements. So looks like we're dealing with sodium nitrate being our soluble substance. I'm sorry, that should have been in blue. Sodium nitrate being our soluble substance, and zinc phosphate is our precipitate, so it gets that down arrow. Last thing, let's balance it. And it looks like we're going to need, in order to get this balanced, we've got 3 sodiums. Let's see, 1 zinc on each side. No, it looks like we've got 3 zinc on the right-hand side, so we'll need a 3 here. That gives us 6 nitrates, so it looks like we're going to need a 6 in front of our nitrates over here. So now that we've got those 6 sodiums, looks like we'll need a 2 here to balance our sodiums, and our phosphates are nicely balanced when we do that at 2 each. So here's our final reaction. Make sure it's clean, no charges, no little random lines in there. Those aqueuses can be there if you want to. Okay, our final one, we've got lithium chloride and we've got copper 2 sulfate. I'm going to show you a little bit of it. Shortcut here so you can check it out before you ever do this. They're both compounds. So we know that the first two elements are going to trade places. So now lithium is going to be with sulfate. Well, let's do it the same way I've done it before. We'll keep copper 2 with the chloride. And we'll do, looks like lithium's going to go with the sulfate now. Now, you could do a shortcut here. We know both of the two on the left are soluble. And you could go ahead and just look up to see, look at your solubility chart without writing this as a formula equation to see if copper 2 chloride and lithium sulfate are going to be soluble, because you can do that by simply checking your solubility chart. Now, I'm not going to do that here. I'm going to go ahead and write it out because it's the notes, but that's just an option. Now, either way, you're still going to have to write down the formulas for these substances, lithium chloride and copper with the sulfate. And lithium chloride, lithium's a +1, chloride's a -1, so no subscripts needed. Copper's +2, sulfate's -2, so no subscripts needed on that one either. Now, if you looked this up, you may have found something already, but I am going to go ahead and finish this up. Whoops. I've got copper with the chloride this time, and lithium with the sulfate. Now, since copper's a +2 and chlorine's a -1, we're going to need a 2 here to get this compound balanced. Since lithium's a +1 and sulfate's a -2, we're going to need a 2 here to balance these. Now, when we go to our solubility chart, we're going to notice that both chloride and sulfide are on the soluble list. So there's chloride. I said sulfide, I meant sulfate. Both chloride and sulfate are on the soluble list, and neither one of them are paired with one of their exceptions. Both of them have either copper or lithium, and none of those are in the insoluble exception list. So it looks like both of these are going to be soluble. Now, what does that tell you? If both of them are soluble, then this reaction does not work. So if that happens, you can simply mark through this, make sure you mark through it, and put no Rxn underneath it, because this reaction isn't going to work. And now we're not going to need to balance it or do anything else, because since both of these are soluble, once again, they're both aqueous, this reaction will not work. It will not form a precipitate. It will not undergo a chemical reaction.